Hello and welcome back. So starting off with a slide, I would just go ahead and jot this down. So these are some good, this is a good rule of thumb to follow. That if your F out or your load is closer to the fulcrum than your input force or where you're pushing, the mechanical advantage or the ideal mechanical advantage is going to be greater than 1. Okay. And we're going to talk about this as a type 2 lever. If the fin is closer to the fulcrum than the load or the FOUT, then the ideal mechanical advantage is going to be less than 1. And this is known as a type 3 lever. You'll write that down in a little bit, or at least make note of it. So FOUT closer to fulcrum, IMA greater than 1. Fin closer to fulcrum, IMA less than 1. Okay, so on to types of levers. There's three types of levers, or 3 classes of levers. Type 1, type 2, type 3, and it all depends on what's in between the other 2 things. There's going to be 3 things: the input force, the fulcrum, and the output force. So whenever there's 3 things, one thing is going to be in the middle. It doesn't have to be like dead middle. It just has to be in between the other 2 things. So, and these will be some easy multiple choice questions. If the fulcrum is between the other 2 things, then it is a type 1 lever. If the fulcrum is between the other 2 things, it's a type 1 lever. If the output force is between the other 2 things, it is a type 2 lever. If the output force is in between the other 2 things, it's a type 2 lever. And if the input force is between the other 2 things, then it is a type 3 lever. Sorry about that. Where were we at? I think we're on type 2. So in a type 2 lever, the load or the thing you're trying to lift is in between the input and the fulcrum, and the fulcrum is at usually at one end. And then type 3 lever, what's in between the other 2 is the input force. That's where you're lifting, and the fulcrum is at one end typically, and the output is at the other end. So anyway, it all depends on what's in between. So fulcrum, FOUT, fin. Okay, so 1, 2, 3. Fulcrum, FOUT, fin. Now, how do these change the direction of the force? So does the type 1 lever change the direction of the force? Sure it does. I push down, the object goes up. Okay. A type 2 does not. This is when you lift the object up, and the object goes up. And a type 3 does not either. Type 3, you lift up, the object goes up as well. So only a type 1 changes the direction of the force. Now, compared to the resistance, can each one make the applied force more, less, or both? So can a type 1, this is the ones that we've been looking at. We've been looking at type 1. We've had the fulcrum in between the other 2, and that's primarily been the one we've been looking at. So right now, this would make this would give you a greater output force, which means your mechanical advantage would be greater than 1. If I slid this to the left over here, it's going to reduce the amount of output force. Your mechanical advantage is going to be less than 1. And if you put it in the middle, the input force and output force are going to be the same, and the mechanical advantage is going to be 1. Type 2s, okay, remember the very first slide we said, and I know it's a lot to remember, if the output force is closer to the fulcrum, like it is here, the output force is closer to the fulcrum than the input, then the mechanical advantage is going to be greater than 1. The output force is going to be multiplied. It's going to be magnified. So this gives you mechanical advantage greater than 1. It magnifies the input force. This gives you a mechanical advantage of less than 1. It reduces, it does the opposite of multiply your input force. but the advantage is since you lose force, you gain distance. These are some examples of these levers. A seesaw would be an example of a type 1 lever with the fulcrum in the middle. A wheelbarrow would be an example of the type 2, where the wheel would be the fulcrum. The load would be the stuff that's in the barrel, and the input force is where you've got your hands on the side, so the load's in the middle, so that would be a type 2. And then a fishing pole would be an example of a type 3, and so would a broom. So you've got the fulcrum would be the end here. You would apply your force with the tip of your hand here, and then the load would be the lure, which is at the very far end of the fishing pole, the lever. And you don't really need it to magnify your force. What you want it to do is magnify your output distance, so that you can cast the lure far. So that's an example of when you want a type 3 lever. What type of lever is this? This is a crowbar. And the key thing here is what's in between the other two. What's in between the other two. And so this right here would be what? That'd be the fulcrum. This would be the output force, and this would be where you would apply your input force. So what's in between the other two is the fulcrum, which means it's a type 1 lever. A pair of bolt cutters. So what do we got over here? Well, this is where you're going to cut the bolt. So this is going to be the output force. Okay. Your fulcrum is going to be over here, and kind of a combination of these two things right here. And then where you're going to apply your input force is going to be on these handles. So this would be an example, if the fulcrum's in the middle, of another example of a type 1 lever. So here's a bottle opener, and so where is this pivoting about? Where's the pivot point on this? The pivot point is over here at the far end. Okay, where we're lifting the cap right here is the output. Okay, and the input force where you're applying your force is over here. So if the output is in between the other two, that makes it a type 2 lever. Okay, and here's a fishing pole, which we already said was a type 3 lever. Okay, a little bit on pulleys. So pulleys can be pretty simple, where you just have a wheel with a groove in it that'll retain a rope, and you throw a rope over the top. And they can get to more complicated, where you've got multiple pulleys in the same block going up and down. This is a cam, an off-centered pulley used in a bow. And so they're pretty cool. They can do some cool things. So simple pulleys, just a wheel with a groove in it to keep a rope on it. And when you pull down, you apply an input force, and the rope pulls up on the load that you're trying to lift, and that's your output force. So this changes the direction of the forces. So what type of lever does that mean it's like? There's only one type that changes the direction, and that's a type 1. So this is like a type 1 lever. Okay, now when I pull down like a meter of rope, okay, is this going to go up more or less or the same than that meter that I pull down? Well, if I pull down a meter of rope, this is going to go up a meter, because unless this rope stretches, it's got to be the same. Okay, so a simple pulley gives you the distances have to be the same, and if the distances are the same, that means that the forces are going to be the same too. Here's my resistance force, 1,000 newtons, and here's my input force, which is 100 newtons. This is my output force, which is 100 newtons. So if I divide those, output divided by input, I'm going to get 1, and this gives you a mechanical advantage of 1. Okay. So this is like a type 1 lever with the fulcrum put in the middle, okay, which is pretty much what this is. Very, very similarly. Changes the direction of the force, and it doesn't change the magnitude of the force. Here we've got a different type of pulley. This is called a movable pulley, and what I've done is I've attached the rope to a roof. Okay, I've brought the rope underneath the pulley, and I've got a hold of that rope, and then I've attached the load directly to the pulley, and I'm going to pull up on this. Okay, now if I look at this, there's actually 2 strands of rope that are pulling up on this pulley. So so even though this is 100 newtons of force that I'm trying to lift, because I've got 2 strands of rope here, I only need 50 newtons of force to balance that, just like I've got over here. The 250 ups balance out with the 100 down. Okay, so now when I pull up on this is a little hard to visualize. In order to lift the weight up 1 meter, I've got to pull up 2 meters of rope, because I'm shortening this strand and I'm shortening that strand, okay, by the same amount. So that's a little tricky to visualize, but so I have to pull up on the input side with twice the distance, but half the force. And again, there's always that trade-off, force and distance. Okay, so this is an example of that movable pulley. So it takes 50 newtons of input force to lift 100 newtons of load. And so if I were to figure out the mechanical advantage of this one, the actual mechanical advantage, it would be 100 divided by 50 would be F out over F in, which would give me 2. Okay, so I get a mechanical advantage of 2. The mechanical advantage, the ideal mechanical advantage, is just how many strands are supporting the load. So in this case, I've got 1 strand supporting the load, and I've got 2 strands supporting the load, supporting that pulley that's pulling up on the load. So this is like a type 2 lever, where this is like the fulcrum, the part that isn't moving. This is the load, and this is your input force. So the output force is in the middle, or is in between the other 2. So that's what gives you the type 2 lever. So this is another example of a movable pulley. This is called a block and tackle. This also has a mechanical advantage of 2. There's only 2 strands that are supporting the pulley that's supporting the load. Okay, this one isn't. So this again just has a mechanical advantage of 2. Now here we've got a little bit more of a complex block and pulley. And so here we've got 1, 2, 3, 4 strands that are supporting that load, and so that gives us a mechanical advantage of 4 in this case. Okay, so which is why it only takes 25 newtons of force to lift this thing up. But again, if the advantage is that we gain force, the trade-off is that we lose what? We lose distance. So I'm going to have to pull a lot of rope here to get this thing to lift. I'm going to have to pull 4 times the rope as I want to get this thing lifted. Okay, so what I want you to do is worksheet 7-2, and that's all the notes for today.